Alright, so today in calculus we'll be talking about the area between two curves. Okay, now I've kind of drawn it out and it's a little bit hazy, but I'm trying to find the area of within here, this region. Okay, now that region is actually a little bit hard to find unless you start thinking about this analytically. And the area is actually going to be the integration from a to b of f of x minus g of x dx. Okay. Now, why is it that formula? Well, if you think about it, the area for this first shape is, or this first curve is going to be everything below it, all the way to the x-axis. Okay, and then the top shape is going to be everything below the actual blue. Okay, now if you notice, there's some overlap there. Okay, and if I'm wanting to find this area in here, I just have to subtract this from this, and what I'm left with is this. And that's why we do the subtraction that way. So let's see a sample problem. Alright, now let's say we look on Desmos and we see this actual graph that is working right here. So the first one, the green one, let's actually change that to a darker color. That is just too dark. There we go. Much better. Okay. Alright. So the first curve is actually going to be y equals 2 minus x squared. And the second curve is going to be y equals negative x. Okay, so what we're going to do is find out that you can set them up equal to each other and solve for x. That's totally fine. But I'll be honest, graphing on Desmos actually helps find the intervals really easily. So we're going to be finding between the interval of negative 1 and 2. Okay, so that's the interval that we'll be looking for. Okay, and so when we go back to write it down, we'll be using these intervals right here. Now, if you notice, I'm going to have some double negatives, so if I simplify this a little bit, I should get just, well, 2 plus x minus x squared, okay, dx. So that should simplify that a little bit. So when I integrate it, what I'm going to be getting is 2x. I'll be getting is 2x plus x squared divided by 2 plus minus x cubed divided by 3. Okay, and I use this notation once again, old school notation of plugging in 2 and then negative 1 right there. Okay, and so when we work this out, obviously we're going to subtract the top. Now some of you guys might be asking, oh hey, why did you put this one first and this one second? Because if you look back at the graph, this one was on top and this one was on the bottom. Okay, alright, so that's why I'm using it that way as I work with it. Okay, so as we plug in stuff, we're going to get 4 plus, let me see, 2 minus 8/3, and then we are going to minus negative 2 plus 1/2 plus 1/3. Okay, so when I'm plugging that in, I'm quickly just doing the calculations in my head as I work with it. Yep, that works. And when you find out the sum, what it's going to be, it's actually going to be 9/2. Okay, all right, and that's kind of cool because it actually divides up the region, just works with it. Okay, now, so once again, just to recap, when you are finding the area between two curves, you take the curve on top and minus the curve on the bottom, and then you integrate from a to b. And if you'd like to figure out which region to do that, either they will give you the information or you graph it and just see what the area is bounded by it, and you just work with it as is. Okay. Alright, but integration, really easy stuff. It's really kind of cool to actually find the area of those two curves. Okay. Alright, that's it. I'll talk to you later. Bye.